Geological significance of the mayapple and the other plants, similar plants that are found in eastern North America and East Asia, excuse me, but not in Europe or in Western Asia. They used to be found in Europe. They can find fossils of them in Europe. Hickory is another plant. You find hickories in East Asia and in North America, but not in Europe. Tulip tree, redbud. The reason is that during the ice ages, which is the last 2 million years, when at least 20 times ice pushed south, in Europe and Western Asia, the ice pushed south, and there's an east-west set of mountain ranges running across. And those plants were wiped out of existence because they could not move south, because there were glaciers coming the other way from the mountains. In eastern North America, there is not an east-west mountain range, and the plants were able to retreat southward all the way to the Gulf Coast. And then when the ice melted, moved right back north again, and it kept on doing that. Asia, West Asia, Himalayas, Hindu Kush, the Southern Mountains did the same thing. Again, in East Asia, though, it was able to move south and back and forth as the ice came back and forth and managed to survive. So that's the geological significance of these, is historical geology, the geological history of the two areas. Okay.
All right.
Okay, this rock is called the Urbana Formation, and this is part of the Laurentian terrain, because these are the shallow water rocks. It does show good bedding. What you're seeing here, though, the rocks are dipping down in this direction. That's a cleavage. That's a tectonic produced by pressure, and it's what's called an axial plane cleavage. If you remember, axial plane has to do with the folds in a rock, and the axial plane of the fold is that plane, imaginary plane, across which the structure basically reflects. So it's the same on one side as the other. Now, when you fold something, the fold axial plane is perpendicular to the pressure. Something else that's also perpendicular to the pressure is the cleavage that develops. So this cleavage here is defining the axial plane of the fold, and that's why it's called axial plane cleavage. This also shows bedding. You can't really see it well from here, but cross over onto the other side, and I'd probably be able to take some rocks up to the stream bed there, in which you can actually see the bedding at an angle to the cleavage. Now, if you've got a cleavage like this, which is about the angle that this cleavage is at, and you've got bedding like this, if the axial plane is acting as a mirror, that means the other side of the fold is going to be coming down like this. So this rock here is going, this side is up, this side is down, and as we go in this direction, we're going lower and lower. We can tell which way is up from the axial plane cleavage relation to the bedding, and we know as we go in this direction, we're going lower. Actually, we're going to climb the mountain to our next outcrop, and although we're climbing the mountain and going higher and higher in elevation, because the steepness of the beds is greater than the steepness of the topography, we'll actually be going down in terms of what the rocks are doing. We'll be going into lower and lower rocks. This is a giant anticline right in through here. And in the center of the anticline, we have the oldest rocks, which is the Sugarloaf Mountain Quartzite. But I won't say more about that now, because we'll be going to look at the Sugarloaf Mountain Quartzite at our next stop. Okay, now some of these rocks actually are calcareous. It's a mixture of clastic sediments and calcite. So this was actually an area that had a fair bit of fine-grained clastic material coming in, but mixing with carbonates that presumably were being produced by organic plants and animals, that is algae and seashells. The metamorphism here is just a little bit too strong so that no fossils have ever been found in this area. Doesn't mean they couldn't be found. It might be that some ambitious geology student is going to come in here and in the calcareous rocks find some fossils, but it ain't been done yet. Now the age of these rocks is supposed to be Cambrian, bottom of the Paleozoic, but the evidence for that is not very good. It's basically the best guess we've got. You can't get radiometric dates on this because there is no zircon produced in these rocks. It's too low grade to have produced zircon. There could well be zircons in these rocks, but the age of the zircon would be the age of the rocks from which the sediment was originally derived, not the age of the rocks that we're seeing here. You wash the zircons off, put them in a sediment, and then metamorphose the sediment to make this rock. And if you find any zircons, you're going to get the age of the earlier rock, not the age of this rock. So you can't get it by radiometric dates. And since nobody's found any fossils in it, you can't do it by fossils. Also, since this area is fault bounded, there are faults on all sides of it, you can't trace the rocks to somewhere else and get the rock's age by finding a date somewhere else and tracing it. So, as I say, it's basically our best guess. Now, the best guess is because these rocks have a similar sequence to rocks that you find over in the Blue Ridge. You find the same sequence of a clean quartz sandstone overlaid by carbonate-bearing rocks over there. And the guess is that they're basically the same rocks as we have here, and therefore you could get the age by getting the dates from the Blue Ridge rocks. The Blue Ridge rocks are full of fossils, so you can get a date there. Generally, that's the best you can do, but it's not something that you should really bet the farm on. And if you can figure out a way to get a better date on this, there's your dissertation right there. It's a wonderful, wonderful research project. Okay, I'm going to go down here and try to find some rock that shows the bedding. Okay, I will bring this up there later so they can see it close up without having to indulge in any heroics.
Plus, I will take a photograph of it up close.
Yeah, this is really I'm going to take this one back because this would be a good one to have in the lab. The bedding here are these lines here, but the cleavage runs like this. So the bedding and the cleavage are at an angle. The beds themselves stand out in relief. These gray beds are worn inward, whereas these black ones are standing out in relief. That's because these gray beds are carbonate. They're basically limestone. And they've dissolved away, leaving the non-limestone layers standing up higher. I did not bring any acid with me this time. I meant to bring some, but neglected to do it.
One year, I remember we did that here.
Yeah, but we have done that. We've taken the acid here, put it on it, and when I get this back to the school, I will demonstrate with the acid there. But this is an excellent example of showing bedding and cleavage very plainly. You can see it over in there as well if you go over and look, but I'll spare you the effort of crossing the street.
You can see a little bit in that rock over there, right? Right there?
Yeah, this shows the same thing. The bedding isn't quite as clear. It looks fairly irregular. This one shows it.
Right.
You can see this from half a mile away.
Right.
Yeah, my wife wants me to throw these pans away. They're getting frayed and stained.
Harold, can you turn off the other camera?
But for a geology
Or are we
field
still
trip,
running?
that's just what you need.
No, I think we're finished.
Okay, there's the bedding, and there's the cleavage.
Is that yours?
Yeah, he dropped part of his camera pieces. Get up, Rupert, I'll get it.
Oh, he got it. He got it.
All
Okay,
right.
so let's get up to the top of Sugarloaf Mountain. Yeah, this again is another chunk of rock showing the cleavage and the bedding. I'll put it in the light here so you get a better view. The bedding runs like this, and the cleavage runs like this. So this I don't think has any of the calcite in it. This is just fine-grained and coarse-grained clastic rock. So it doesn't show the relief that the other one has where the limestone actually wore away. But still, yeah, I'll take this one back too. This would be a good one to
Okay,
have in the
we'll
lab.
take both those rocks back.
Yep.
Give me one of them. Where's the other one?
Right there.
Okay, and I'll separate them from the.
Thank you.
Okay, now Dennis doesn't want that one, but I want it. Pick up that one. That goes in the trunk. These two go elsewhere.
Yeah, that's